Okay, so chapter 4 is all about lines. So we're looking at the different forms of the equation of a line and graphing lines from those different forms of the equation. So the different forms that we are going to study are standard form, slope-intercept form, and point-slope form. So in this section, we are studying standard form. And then in section 4.3, we'll look at slope-intercept form, and then section 4.4, we'll study Miss Dorset's favorite form of the equation of a line, which is point-slope form, and you'll see why when we get there. Okay, so standard form of the equation of a line is ax plus by equals to c, where a, b, and c are integers, and a is supposed to be a positive integer if you're looking at strict standard form. But really, the biggest characteristic of standard form is the fact that both variable terms are on the same side of the equation. So okay, and a and b cannot both be 0, and that should make sense, because if we had 0x plus 0y equals to some value of c, well, 0 times a variable is still going to be 0, so both of our variables would go away, and we would have no variable, so we wouldn't have an equation at all. Okay, so a and b cannot both be 0, but we'll look at some examples in a little bit of when a is equal to 0 or when b is equal to 0. So standard form is useful for graphing a line using the x and the y intercepts. We could make a table of values and just choose values to substitute in for x and then solve for those values of y, or the other way around. However, 2 points define a line. So between any 2 points, there is a unique line that will pass through those 2 points. So it's easy to find the x and the y intercepts, and then you have 2 points and you can draw the line that passes through them. So let's talk about how we can go about finding x and y intercepts. And first, let's talk about what an x-intercept is. So an x-intercept is a point that lies on the x-axis. So an example of an x-intercept could be like the point, well, let me get a color here. Could be like the point 3, 0. Okay, or how about -2, 0? Okay, or -5, 0. And if you notice, all of those points that lie on the x-axis and could be considered x-intercepts have a y value of 0. So to find the x-intercept of a line, you can set y equal to 0 and then solve for the x value that corresponds to it. So then the intercept, the x-intercept, should be represented as an ordered pair because that ordered pair corresponds to a point on the graph. Now to find the y-intercept, let's kind of go through the same process. A y-intercept is a point that lies on the y-axis. So an example of a y-intercept would be like 0, 4, okay, or 0, 2. Or 0, -3. So notice for all of those points that lie on the y-axis, x is equal to 0. So if you have an equation, you can set x equals to 0 and then solve for y. And then you can represent the ordered pair as 0, whatever that y value is. Okay, so we have an equation that is in standard form, and we are going to find the x and the y intercept and then graph the line that would represent this equation. So let's start with our x-intercept. And we know the x-intercept is going to be some number, 0. So let's go ahead and substitute 0 in for y. okay? And when we simplify that, we'll have 2x equals to 8. If we divide by 2 on each side of the equation, then we'll have x equals to 4. So we're using our equation solving skills still. So we have the point 4, 0 is our x-intercept, and we can go ahead and graph that. Okay, and then let's find our y-intercept. And we know the y-intercept will be of the form 0, a number. So we can substitute 0 in for x and then solve for y. So we'll have negative y equals to 8. And if we divide by negative 1 on each side, we'll get y is equal to negative 8. So we can graph that point. Okay, and now we have 2 points which define a line, and we can draw the line that passes through those 2 points. Now I make sure you're drawing arrows on the end. Oh, I don't like this line. I'm going to redraw it. So make sure you're drawing arrows at the ends of your line. I'm drawing my line so it extends through my graph. But make sure you're drawing arrows to represent the fact that the line continues on in both directions, right? As x approaches positive infinity and as x approaches negative infinity, there's going to be points. All right, let's do another example. So we're again graphing an equation, the equation of a line that is in standard form. And we're doing that by finding the x and the y-intercepts. So to find the x-intercept, again, we know that y will be 0. We need to solve for the x value. So 2x plus 3 times 0 equals to negative 12. 2x equals to negative 12. And divide by 2 on each side of the equation, and we'll get x equals to negative 6. Okay, graph that point. And then our y-intercept will be 0, and we need to solve for y. So 2 times 0 plus 3y equals to negative 12. That's just going to be 3y equals to negative 12. And if we divide by 3 on each side of the equation, we'll get y equals to negative 4. So 0, negative 4. Now we can draw the line that passes through those 2 points. No problem. The x and the y-intercepts are not the only points that you can find. Like, you can choose any real number to substitute in for x and then solve for the y value, or any real number to substitute in for y and then solve for the x value. So I just choose to solve for the x and the y-intercepts because, first of all, it's important to know how to solve for x and y-intercepts, because that's going to come up later for different types of graphs in equations that we study. For finding the x and the y-intercept, it's going to be the same process that we're using here. But it's also possible to find other points. So for example, if we wanted to find the y value that went with x equals to 2, we could substitute 2 in for x and then solve for y. So that would be 4 plus 3y equals to negative 12. When we subtract by 4 on each side, we'll get, what is that, negative 16, right? And then y would be equal to negative 16 thirds. Oh, that's not such a fun one to find. But 2, so negative 16 thirds is negative 5 1/3. And let's see, does that look like it matches up? Yeah, it kind of does, right? So negative 5 1/3. It looks like that our line is kind of passing through that. Maybe we need to shift our line down a little bit. But my point is, you can find additional points. It's just x and y intercepts are going to probably be the most efficient to find, like the fastest to be able to find. And it's important to know how to find them. Okay, here's a U try. This equation is technically not in like strict standard form because of the leading coefficient of -1, but because both variables are on one side of the equation, we consider this to be in kind of a non-strict standard form. So I'm going to leave that for you guys as a U try. So let's look at horizontal and vertical lines. So consider an equation where a is equal to 0. So it's of the form 0x plus by equals to c. Well, then we would just end up with by equals to c. And if you isolate y by dividing by b on each side, you would get y is equal to c over b. Do not get hung up on the c's and b's, the letters here. This just ends up, the equation just ends up being equal to y equals to a constant. Spell constant wrong. Okay, so y equals to a number. Okay, we'll give you a horizontal line. And you guys know what horizontal lines look like. So let's go ahead and draw a horizontal line. So how about here? And let's identify some points that lie on this line. So we have the point 0, 3, 4, 3, -3, 3. So notice what is the same. Like, notice what is constant about all three of these points. The y value is equal to 3. The x value varies, but the y value is equal to 3. So the equation of this horizontal line would be y equals to 3. Okay, I'll give you another example. Okay, so let's look at points here. So we have 0, -2. We have 4, -2. And we have -5, -2. So every point that lies on this horizontal line has a y value of -2. So the equation is y equals to -2. Okay, so now what if b were equal to 0? Then we would have ax plus 0y equals to c. So that's just ax equals to c. If you divide by a on each side, you get x equals to c over a. Again, do not get hung up with the letters. It's really just the equation is x equals to a constant. Is the equation of a vertical line. And let's go ahead and draw a vertical line on here. I'm going to erase these, just, you guys don't have to erase them, but I'm going to erase them just so that we can see better. So I'm going to draw a vertical line. You guys know what a vertical line looks like. Didn't line up very nicely. Okay, so let's identify some points that lie on this line. We have the point 4, 2, 4, 0, -4, -3. So notice that for each of those points, the constant is 4, right? Or for each of those points, x is equal to 4. So the equation of this line is x equals to 4. So horizontal lines come in the form of y equals to a number. Vertical lines come in the form of x equals to a number. All right, so let's graph these lines. So x equals to -3. Okay, so that means that all of the points that lie on this line are going to have an x value of -3. So that's going to be a vertical line. Okay, at x equals to -3. So I'm going to draw the line and I'm going to label it. Okay, because every point that lies on that line will have an x coordinate of -3. All right, so let's then look at y equals to 7. So every point on that line will have a y value of 7, or a y coordinate of 7. So that's going to be a horizontal line. Okay, label that y equals to 7. Okay, x equals to 6 will be a vertical line. For every point that lies on the line, we'll have an x coordinate of 6. Okay, let's see if there's one I wanted to add. Oh, let's add a couple here. So for D, what if we had y equals to 0? Okay, y equals to 0 means that every point that lies on the line will have a y coordinate of 0. So that's going to be a horizontal line. And it's actually, that line is going to end up overlapping with the x-axis. Isn't that funny? Y equals to 0 ends up overlapping with the x-axis. Let's do one more. How about x equals to 0? Well, every point that lies on that line is going to have an x coordinate of 0. It's going to be a vertical line that actually ends up overlapping with the y-axis. Okay, and I should label x-axis, y-axis. Okay, so that's it for this section. In the next section, we will be looking at graphing lines from equations that are in slope-intercept form.